I mean, what are the tools available, and what are the various areas where we need to concentrate, and how this Kubernetes ecosystem is growing in various areas. So in this, I think there is something called CNCF Trail Map. Got a chance to take a look earlier. So I think today let's go a bit deeper on the CNCF Trail Map. So this is CNCF as a group. It has lot of tools in the ecosystem which we'll go through in a moment. But in that, if you have to take subset, so the subset is a smaller version of this bigger landscape. Is what is this trail map is. So this trail map. So I mean there are a lot of tools in these areas, but I think from a developer point of view, what will be more important from Kubernetes learning point of view? So this CNCF Trail Map is a good area to start. So, sorry, could you hear me?
Yeah.
Okay.
Yeah.
Got stuck.
Yeah, one of the good thing about this trail map is they grouped it also, right?
Yeah.
That's a very good.
Yeah. Otherwise, this list is very big. So that way it is good. Okay. Yeah. So this trail map, I don't know whether you could see this. Let me see if I could zoom in. Browser is stuck. Okay. While it is loading, let me go through this. So if you look at this is the trail map. The containerization is the first thing that you need to start. Once you containerize your applications, the obvious logical step would be to introduce CI/CD into the platform, and then we should also introduce orchestration. Some delay in my. Yeah. So this containerization, CI/CD, orchestration, observability and analysis. Oops.
She thinks herself too much.
Yeah. How about now? Is it better?
Yeah.
Okay. Yeah. So CI/CD, then orchestration and application definition, observability, service proxy discovery mesh, networking policy security, distributed databases and storage, streaming and messaging, content registry and run software distribution. So there are a lot of things are there, but I think makes it may not be suitable for all the projects who want to migrate into CNCF, but this will give you some basics of what are the important items that we need to pick. So of course, it all starts with containerization. Any CNCF migration, any application you want to migrate to a cloud-native journey, it starts with containerization. So I think, of course, mostly used containers are Docker, of course, and also there is application dependencies. Everything should be also has to be Dockerized. Let's say you're depending on some other application, then that also has to be Dockerized. So everything should be Dockerized. And over time, you should probably aspire for splitting into suitable microservices. So that is what, if it is a monolithic, then you should also consider thinking about microservices-based approach. So that should be the first step in the migration. Assuming that you already have a monolithic application which is running on your on-premise, then you wanted to migrate to a cloud-native journey. You want to embark into a cloud-native journey. The first thing is consider about splitting into microservices, and also consider containerizing all the applications or microservices. So these are the first things to start with. So as a second step, once you're done with that, now we have microservices and they're all containerized. You should have CI/CD setup, which is very good very important tool in this current journey. So the CI/CD tools, of course, it is a lot of tools are there, even for Jenkins or any other popular tools. But I think CNCF has a very good tool specific for CI/CD is Argo. So I read about Argo. Argo is more. It is built for Kubernetes. So Argo is a CI/CD platform built for Kubernetes, and it is all the it can support all the jobs, deployments, application workflows. Then there's a popular framework in the CI/CD landscape which is called GitOps. So the GitOps, meaning everything should be checked into Git. Even the operations process also has to follow the Git process. So the GitOps methodology is the basic methodology that is considered in this Argo. So and also probably also natural progression would be even to use MLOps. So MLOps, I mean, I'm talking machine learning operations. So I think that is also becoming popular now. So this Argo is a Kubernetes-centric CI/CD tool, which can bring you the flavor of the complete Kubernetes tooling around integrations and also following the popular GitOps and MLOps methodologies. So rest of it is all same. I mean, nothing different than any other Jenkins where CI/CD process is all same. But the CD is more into Kubernetes. That is a bit different. The CA process is more or less same, but CD is deployment into Kubernetes. So Kubernetes could be on cloud or on premise. But the CNCF tool, Argo supports both. And there is, I mean, if you observe this, if I zoom out, you can see something called, oh my God, sorry. There's something called CNCF incubating. There are some stages in this project. If you see, some of them are, these are various stages in CNCF. It tells you about what is the project status. Since there are a lot of projects, each project in CNCF landscape, which will go here. So each has a status called either graduated or incubating. So like with graduated and incubating, or these are the two statuses. So graduated is like it is widely used and widely adopted, and it is like graduated. It is graduated to next stages. Incubating is just in the process of getting into a graduated stage. So it is just cooking. It's not completely done yet, but it is just cooking. So it will take some more time to go to a graduated stage. But graduated is like it is widely used and heavily used, and it's already running in production, and a lot of users and community is built. So those, that is all graduated. So every project in Kubernetes landscape, they go through a cycle of there are some steps where when the project can go to graduated stage and when project can go to incubated state. Incubated is even even to come to incubated state, there are some requirements. So initially it will not be incubated. So initially there will not be any status, but based on the project, the status will be changed to incubating. The next advanced level is the graduation. So yeah, so this Argo is an incubation status project in the world of CI/CD. So that's so if you go through more, I mean, the setup CI/CD process, so that changes to a source code automatically result in a new container being built, tested, deployed, and eventually perhaps to production. So set up automated tools, rollbacks, testing, Argo set up Kubernetes Native tools, and deploying and running jobs, applications works, workflows, events using GitOps paradigms such as continuous and progressive delivery and MLOps. So that's a summary of this Argo. Then next is this orchestration and application definition. So this, assuming that you already have a CI/CD, obviously when you have to go for a deployment, assuming it is a Kubernetes is your platform. So there comes there are some orchestration frameworks which you can use, which are of course Kubernetes is always is a deployment platform, which is a market-leading orchestration solution. But to deploy into Kubernetes, so you need to write a lot of YAMLs. So this YAMLs, managing these YAMLs is a bit of problem when you have to do with multiple YAMLs. That's where there are some tools called Helm, which is also getting a lot of traction now. The Helm also follows a process of they apply the concept called charts. So there will be a lot of charts that each project or each dependencies that you need is in a Helm is a chart. So you can deploy a lot of charts, and it follows. It also follows YAML, but the only thing is it is more user friendlier than the Kubernetes YAMLs, and it also follows a lot of advantages of it came from the concept of Red Hat concepts mostly primarily the I mean you can the hierarchy is all it can be maintained and like you need to develop everything from scratch. I mean, you can use ready-made templates that can be the template-based framework. So there's a template that can be used, and also it's similar to Ansible. If people who has worked in Ansible, um, it's more similar. It is all developed from the concept of templating. So I mean, yeah. Once we go into details, we will understand more. I mean, we will go through Helm, which is very interesting project. It is getting a lot of popularity. So Helm is one such project which is helping you to deploy stuff to the Kubernetes. So this is also getting a lot of traction. So yeah, and probably I'm just taking a quick route of just interesting to uh, see this to show this Helm charts just to get a feel of what are these. This is if you look at here, there are a lot of charts that you can download from Helm. So more or less, your charts will. There are a lot of charts that can pick up, but I think it will help you to manage Kubernetes, and also it will help you to define, install, and upgrade any complex applications in Kubernetes. So that is where this is primarily into. For example, like in just of course the installation process is this, but I think main advantage is the charts. So you have a lot of charts that you can download and set up. Um, so of course you need to install Helm. So once you install Helm, so you can install it. So how to once you install Helm, like Helm is a command line, so utility. So Helm repo update. If you give it will update all the repos, and Helm install command is to install a specific chart. So whatever you want to install any software, it is less than similar to npm install. I mean, if you worked in JavaScript ecosystem, right? So npm tool is a lot popular. So it is the same functionality. Brew also is similar to in Mac. So you can install all the binaries, all the dependencies, and all these are, for example, I want to install MySQL from Bitnami. So Helm install Bitnami MySQL. So this is a chart of MySQL dependency that is already available and installed in the repo of Helm. So you can install it, and then it will automatically install stuff for you. Then it's similar to Kubernetes command like Helm ls. Once it is installed, you can see the image which got downloaded. And of course, you can Helm status. Want to uninstall, you can just uninstall it. It's more a CLI. And also the beauty here is more once you go to the charts, it has artifact hub. So it is similar to Docker Hub. It is called artifact hub, where you can it has a lot of packages pre-built installed, which is, for example, you want to install a Kafka server. So Kafka setup is all there. So you can download, go to here, and there's something called every project will have a Helm chart. So if you look at this is what the template which I was referring. So here, yeah, if you want to install like Kafka setup, you just need to run helm install Bitnami Kafka, so that will fetch you. It is similar to Docker Hub. I mean, if you remember, Docker Hub also will have similar functionality, but it's more artifact hub here. So, and the templates is what is more useful. So if you want to extend this framework, So this is a templating language. Whatever you put under braces, right? So this is a templating language. So there you can install what I mean. These are all like global configuration variables, which will be outside like environmental variables. So based on the environmental variables, your installation can happen so automatically. So for example, this is actually like creating a config map it's creating Kubernetes config map. So, but I mean, the advantage here, of course, you can write the same YAML file in Kubernetes language also, but if you have multiple versions or multiple servers you need to deploy, and based on each environment, the configuration is different. So each node, the configuration is different. So you have such complexities that will come. So that's where Helm will shine. So of course, otherwise you can write this in same Kubernetes without. But only thing is in Kubernetes you don't have this kind of a if conditional in a YAML. So that is what is Helm is giving you on top. So at the end, it is a Kubernetes YAML file only. But what Helm is giving you is this this template language on top. So like you can add this if conditional variables. So it is, if you remember, it is exactly concept on top of the YAML. So yeah, so that's about a quick drop. So summary, Helm is something like your Maven repository of our Maven repository or Gradle repository of your container images. So that is one. With basically, you can use Helm install commands to download or install any software. That is one. Um, but apart from that, it is also gives you the power of Helm is more in the templates. So you can create templates like how I showed, and you can write your own templating language YAML files and store it in a repo, and use that for all the Kubernetes deployment. So of course you need Kubernetes for this at the end. Kubernetes is not going away. It is just making a conditional YAML files is what the advantage that Helm is giving you on top. So yeah, probably I'll just stop here. So any questions here?
Yeah, just a wrapper. That's it. So
Yeah,
all
yeah,
those dollar sign things will be replaced properly.
exactly.
Yeah. So, but one thing is as more and more Kubernetes constructs are getting complex with CRDs and a lot more customizations. This is very handy because everything is going towards YAMLified, and once you have too much of YAML, this is going to help us to package it, deploy it consistently across applications.
Yeah,
So there was two products, right? Like what is that? OpenShift, right? OpenShift is Kubernetes, and that is just simple YAML. It's Docker Hub based, right? Or at least some of the components of Docker derivation, like Docker Compose or whatever. There is another product based on Kubernetes, which is called Diamante. It's a database thing. They used exclusively Helm charts. That's so it's just another. It's like Unix flavors. You have various flavors of Kubernetes in there. So
Yeah, but at the end of the day,
yeah,
installation of the Kubernetes is simplified. It's a package manager. That's it.
yeah.
So that it helps you to package your runtime artifacts across dev to the QA to the prod, so that you don't maintain the versions three different ways. All you say it is the whatever to be variant that is being parameterized, and wherever that if a branch should be done, that could be done, so that you maintain only one code of the YAML to install across different applications, different environments.
yeah, that's true. Yes. Yeah. So this is where this again at the end, as Srini said, it is a CL like command line utility plus a wrapper for writing a Kubernetes YAML files. That's where this Helm comes into picture. So let's just move on further. Yeah. So yeah, the natural progression is, of course, once you go to the deployment side, then to Kubernetes, so you need to install a proper Kubernetes platform. I mean, either it's on-premise or on cloud, or I mean, it's all talking about installation of Kubernetes or managed Kubernetes, which is given by cloud. So even you can install the cloud on bare metals on cloud. I mean, you can create your own. You can have simple virtual machines so created as a cluster, and you can install Kubernetes on cloud as well. So if let's say if you're taking that route, it's always good to use a certified Kubernetes distribution. So the certified Kubernetes. I mean, there are a lot of Kubernetes distributions available. Each has a lot of flavors. So this cncf.io/ck. So this this has a lot of Kubernetes flavors. So that that can, this is all certified Kubernetes. So it is. I mean, CNCF apart from the developer certifications, it also gives a vendor certification. So every vendor who is outsourcing, who is giving a setup of infrastructure, managed infrastructure services, they also can be certified by CNCF. So these are all CNCF certified platform vendors where you can rely on them. So yeah, so this is a lot of people, they get a Kubernetes certified Kubernetes logo, and these are various companies who are offering a certified Kubernetes from certified CNCF Kubernetes. So of course AWS is also there here. Yeah, these are mostly, they're all from China. If you see all this Cisco.
Diamanti is there, Gnani.
Who is that?
Diamanti.
Diamanti, yeah, Diamanti. Okay,
Diamanti.
right.
Yeah. Yeah.
See?
So.
That's,
and we should put agile rules here, man.
You are compliant with everybody, right?
Yeah.
I have to certify myself and certify others.
Yeah. Because HP, IBM, I mean, all this Mirantis is what is the Docker enterprise Docker version. So yeah. So the Red Hat OpenShift, so Platform 9. So yeah. So these are all the certified Kubernetes vendors. So yeah. So here, this is what this landscape says. So it says that market leading orchestration solution, which is Kubernetes, but you should select a proper certified hosted platforms. Of course, help charts help you to define, install, and upgrade even a complex Kubernetes application setup. So that completes this orchestration part. So now we're done with orchestration, and your application is live. So far, basically, you containerized it, use CI/CD, and then you deployed your software onto Kubernetes. Now your day two problems will come. So your application is running in production, and the day two problem starts. I mean, first important thing that you should be able to observe if something goes down. So that's where this observability stuff will come. So as part of observability and analysis, these are the prominent tools which are populated or graduated from in the CNCF landscape. Of course, Prometheus is now raging like anything. So it is almost all the companies now moving towards Prometheus as their observability platform. So it gives a lot of tools, I mean, visualization platform, which can easily help you to find out the metrics that are the CPU spikes or your network issues or your. So it gives complete observability of your Kubernetes platform. So and there are a lot of ready-made templates in Prometheus which you can use, and a lot of everything is open source, so you can write your own custom functionality and also host it. So yeah, so Prometheus comes under the monitoring. So quick solutions for monitoring, logging. Yeah, logging. This Fluentd is mostly a logging tool. So this Fluentd. I mean, most of the problem in Kubernetes is that Kubernetes doesn't tell you or doesn't give any integration to logging framework. So of course, Kubernetes generates a lot of logs. I mean, all these logs that are from various microservices, they're all pods. So, but once, as you know, the pod life is very short, right? So it can die down anytime. So once it dies down, even the logs also will die down. So 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 it is a good framework to a good. So always every Kubernetes architecture requires to export the logs from the containers and put it into a safe place. So that's where this Fluentd's role will come in. So of course, it is not just exporting it. It also gives a lot of integration to a lot of logging frameworks also. And by this itself is a logging framework as well, but it also exposes logging framework with other popular products also in the logging space. So that's where this logging area, this Fluentd will shine, which has integration with the Kubernetes. Then, of course, this is all microservices will have a problem of tracing. So, I mean, one, let's say shopping cart example. In a shopping cart example, there will be at least by the time you buy something, there will be at least minimum 5 to 10 microservices will be called. So, and every microservices will have their own logs, which will be intercepted one over the other, and we don't know if you want to see a complete flow, we don't know which is first and which is next. I mean, the logs will be all scattered. So that's where I mean, there comes a problem of tracing. How will you trace the flow when the logs are scattered and they're in different machines, and each microservice is running in different nodes? So there should be some way to collate all the logs in one place and see them, and also complete trace if some issue happens, how to trace for the logs. So this is a very common problem in microservices. So that's where this tool of Jaeger, which is again a Cncf graduated product, this it gives it addresses that issue with giving proper tracing tools on top of the logs. And Jaeger is follows. I mean, there are a lot of tracing. Just to give some background, this tracing. A lot of vendors have implemented their own ways, and it was a bit scattered 2 years back. But I think now immediately the community realized that, and they introduced a concept called open tracing. So open tracing framework is now a popular. It gives some set of guidelines on how a tracing should work, and uh, and and now most of the tools who are working on tracing, it's always good practice to refer this open tracing guidelines. So yeah, for example, Jaeger is one of such open tracing compatible tool. So open tracing is a guideline, and that guidelines are implemented in Jaeger. So if you're picking any tracing tools in your landscape, ensure that tracing tool is open tracing compatible. So I mean that is a feature, and Kubernetes recommends the tools to be open tracing compatibility. So yeah, so this Jaeger is one such tool which is already in graduated stage, which can help you in the open tracing, solving the tracing problem in microservices. And of course, open tracing itself is a is a set of, it's more of a guidelines and steps to be followed. So that itself is a CNCF project. So and this tracing implementer is Jaeger. So this is the guidelines and this is the implementer. So yeah, so this, but see, open tracing is an incubating stage, but yeah, Jaeger is the graduated stage. Okay, so now so with these tools.
So one thing, Sham,
Mhm.
Fluentd, right, is mostly about taking all the logs and making it appear from all the containers, right? That was the original intent, right? Fluentd, when did it become monitoring or observing actually?
I mean, this is logging.
Logging
It's
layer.
purely logging layer. Yeah. I mean, this is all combination of tools. I mean, this is Prometheus.
Also, it is not one is replacing the other. It's just
No. I
maybe
mean, say,
having.
so Prometheus is for monitoring. Sorry, I should be very clear. So Prometheus comes into monitoring space. Fluentd comes into logging space, and Jaeger comes into tracing space.
Oh, okay.
So yeah, so this is a monitoring tool. This is a logging tool, and this is tracing. So, and this is a tracing framework. So, yeah. So this Fluentd is, if you see here, I think this is also a very interesting tool. I think probably you would have heard the ELK stack, right? Elastic Log Stash Kibana. So it is an extension of that, but it is more from day one. It is following the Kubernetes structure, so that's why it is more popular in this Kubernetes ecosystem. But at the end, Fluentd follows all the good practices. We'll just go here. Yeah. So if you take here, when before Fluentd, it will be something like this. I mean, there are a lot of applications. Each application have a lot of log files and all scattered across. So what Fluentd does is it follows the concept of filter buffer route. So it is just a median in between your systems which generate logs and and the monitoring or storage or archival or analysis tools. So this guy is in between these two. So mostly your logs are generally used for log analytics or your monitoring or logging or alerting from the logs. So it's more of analysis by logs. So these are the various utilities on the logs. That's on the right hand side. The At the left hand side you see a lot of sources which generate logs. So the Fluentd addresses these three. So basically, you can filter logs, but let's say you don't want to take all the logs for analysis, so you can filter that. Also, you can gradually you want to store the data into some archiving storage like Amazon S3. Then you can buffer them. Or you can write a routing rule as and when you get some log, push it to this. So you can write some routing rules also. So it is more consolidated logging. So on the left hand side, it doesn't say Kubernetes, but now this Kubernetes logs are also app logs is Kubernetes logs. It's the app front end and back end. They are all running in Kubernetes. So the pod logs are one sources, and you can get a unified logging mechanism using this layer. So the logic at the end, if you let's look at this architecture. Yeah, I think this is another important aspect. So, I mean, this most of the data that on the destination side, right? So here, mostly the Hadoop ecosystem and logging framework is more for a big data requirement for log analytics. So that it supports all the popular big data frameworks or data formats, protobuf, Apache Thrift and Message Pack. And also it gives sort of integration to various. I mean, it has something called aggregator also, so it can aggregate the logs over a period of time and then push it. I mean, it need not every time you get a log, it's not required to push. So it has a mechanism of aggregating the logs. Of course, it's a backup aspect. So this, as it is mentioned in the diagram, right, that various data sources, I mean, This doesn't talk about Kubernetes specific, but you can imagine that this also a Kubernetes, a Fluentd. Imagine that this is a running on Kubernetes. The data source is in Kubernetes. So mostly this logging framework, this Fluentd, will be acting as a sidecar container. So this it will fetch the logs from your main application or microservice, and then it will push it to our aggregator, and aggregator will aggregate the logs. It did not as and when it's not required to push it. It will wait for some time, and also it can do the aggregation logic on top of that, and then probably push it to a destination, which could be an S3 or it could be a Hadoop ecosystem or some destination, so it can push it. So yeah, summary, it is a log aggregator. So one binary file to tell. This is more log aggregator and pushing the logs to implementing the buffer routing concept. So yes, so yeah, I was looking for this architecture. It is interesting to see that it's completely developed on open source. Probably I was reading some Elk versus Fluentd. So this is also a good read. So this this Logstash Kibana is all popular, but I think this now with this Fluentd, it has almost replaced Logstash. I mean, Logstash is Elastic Logstash Kibana. So this is Logstash part in L is more or less is what is Fluentd is doing. So now it has become EFK. I mean, the Logstash L is now replaced with F. So Elastic is still there. Elastic is the source of all your logs, which can maintain all the logs in a database of Elastic, so it can retrieve data faster. But Logstash was the older version, but it's not very Kubernetes friendly. And this L is now replaced with F. So Fluentd and then Kibana is for visualization. So EFK is the new trend now. So after kind of replacing the Logstash. So yeah. So of course, if you see the advantages are this routing of logs, like putting if-else conditions. So if this condition, if this logs are from this server, then push it to this place. So like you can write a lot of routing logic. Of course, it has a lot of plugins where it can extend. It can extend a lot of plugins to all the popular frameworks, and also it can transport the logs to various sources from and destinations. High volume logging, so it uses there's a popular tool called Beats. Beats is another product from Elastic itself, which is very lightweight, and it has become so popular. So Elastic Beats and Fluent Beat I mean, Elastic is now giving Fluent support. So even though Logstash was more popular, but I think Elastic Beat and Fluentd are now become more smaller footprints compared to the bigger versions, and they are Kubernetes compatible. So yeah, so log parsing, Docker support, enterprise support is also there. So yeah, so that's where this area of logging comes into picture. Yeah, so this is generally a routing this is how it will look like. Again, similar to templating language. If log level is with error and deployment is in production, then send this message to PagerDuty. So this is one source and this is one destination. Sending a message to PagerDuty is one destination. So likewise, you can write a lot of rules here in a easily understandable format, and this rule can be applied on a log. And also, you can apply a lot of filter conditions as well. So it uses a pattern called grok pattern. So using this grok pattern, you can tell. Let's say you are interested in guest host name is this, then the host name is having this guest socket get host name. Then you apply this filter logic on the log. So it will send a subset of logs, not the entire logs. So, or you can apply by date. Or apply by logger levels. So, like you can apply a lot of filtering logic on this, even in popular language. Yeah, so that's about
Fluentd
the.
is more agile rules, man.
Sorry?
Fluentd is following the agile rules.
Agile rules. Yeah. Yeah. Yeah, it's more rules for logs. I mean, that's. Yeah, I mean, it is just a one. Rules is one piece, but it's more having integration to the various sources and various destinations. So yeah, typical log extraction, uh, log filtering, and log publishing. So that is the space that Fluentd will come into picture. So yeah, let's go back to our map. Okay. So yeah, so that's Prometheus, Fluentd, Jaeger. So assuming that you implemented all this observability and analytics, there comes the next, which is to handle the networking piece. So the networking piece will come into picture when you have to deploy, when you download some application and it is now working on a local and it's all fine, but let's say you want to um, use service proxy because all your applications are running on as microservices. So assuming you have a lot of microservices running, and you need to have a proper load balancing, domain management, because every microservice will have a domain. So the domain management, the DNS, for example. So the DNS management, then of course the load balancing part. And also the routing and health check. So basically the load balancer. I mean, if you have to summarize, it is more domain management and the load balancer features. So that is
So,
where. Yeah.
yeah, one thing about the Fluentd, I just recollect one of the question in the Kubernetes development certification is multi-container part with the Fluentd, so that you could do your log aggregation. I got that question, and I didn't have time to attempt it. Now just recollect the question. So that is where the popularity came. So as you have containers, now you want as a containers you have multi-language Docker. In a one part you could have multiple containers, and one of the sidecar could be this Fluentd container, which reads the log across the other containers and try to have one consolidated log. You don't have to go to Java log and Python log and those kind of things, because each of the container will have the log specific to that particular application. But this is an aggregation log as a sidecar, so that you could. So the one of the scenario was like you have a front end application in Java that went to the middleware application in some Python or something. So if you want to do a log aggregation, then usually way we do is we do the Java log first, then Python log, then try to correlate. But now this kind of sidecar, what they could do is they could look at both your log and aggregate it using the timestamp, so that you get the holistic picture of your application rather than going to the individual application. And so this brings one of the important things, like this is a real use case to have multiple containers, and your history of what is happening in your application is spread across the logs. Your sidecar can give the bigger picture of the story, and that is being bring by the Cncf framework like a Fluentd very easily. Yeah.
Yeah, that's true. Right. So that I think that this is a perfect sidecar container. I mean, in fact, all these three are sidecar containers. I mean, if you see, Prometheus need metrics. So I mean, to display the data. I mean, probably some of you have seen this Prometheus, but I think Prometheus is more a metric generator tool. So so even in our day-to-day work also we use this tool. Prometheus maybe is coming. Prometheus, okay. So there is a movie called Prometheus. So so this is the visualization tool then where you can see Grafana is a visualization integration, but Grafana is like you can see the output in a proper graph like this. For example, if you're interested in, I'm now talking about Prometheus more, where you need, each microservices or if you want to know what is the metric in terms of the size of the CPU utilization or network utilization or memory utilization. So all these aspects, they're all service level monitoring. So how to monitor your services? So for that you this Prometheus is a um, is a data generator for, I mean, or storage platform of the metrics. So you should, it's all will be running along with your microservice, but this is a small utility which will fetch the health parameters of your microservice, and then it will generate, it will store the data into Prometheus DB. Prometheus is a DB at the end. Prometheus stores the data, it's a time series DB. So it stores the time series data in the time series DB, and of course then it's a DB. So you need some visualization tool to show the analytics output. That's where Grafana is a co-brother, as a brother of this to Prometheus. The Grafana will give you a visualization of the data, which is at the face of this Prometheus. So yeah, you can see a lot of fancy graphs in the Grafana. So combination of Prometheus and Grafana is a proper tool for monitoring aspect in Kubernetes world. Okay, so let's move on. The trail map. Yeah, so we're discussing about the service proxy. So yeah, this I mean, assuming that you have a lot of microservices, so it is very difficult to discover the services first of all. So because assuming since from the knowledge of the Kubernetes that we have, every microservice is a pod. Okay, the pod every time it can die down and come back. So the IP address can change for a pod. So there should be a layer on top, which is, if you remember, we discussed about the Kubernetes service. So the service layer is what will know which pod what is the IP of the pod at any given time, and what is the health of the pod, and route the traffic to that pod. So that concept is overall it is there. If you see, it has to discover the services, and also it should maintain the health of the service. So which means it's more towards a mesh. So if you understand the health of each microservice, a lot of microservices will be running, and there is a layer on top of which which is acting as a load balancer, and it is trying to get the health of the microservices, and then based on the health, it will decide which service is healthy. It will route the traffic to that particular microservice. So that entire concept, along with that. On top of that, you need to have a DNS. So every pod requires an IP address, so which is a networking component. So we should have a generated DNS, so it's easily identifiable. So remaining as an IP, you can associate a DNS so that it is easy to recognize. So all these networking pieces are all important when you go for a microservice. So that's where this tools of ecosystem in Kubernetes, which is more service proxy discover and mesh category. So that's where Envoy CoreDNS and LinkerD. I mean, you can relate Envoy is for service proxy. Discovery is for discovery is more discovery based on DNS. So that's why it's so discovery will come here. So CoreDNS and mesh is like you're managing your microservices in a better way based on health parameters and routing the traffic and a lot of other stuff on top of microservices is all given by a mesh framework which is LinkerD. So that is a set of what Cncf promotes, and if you look at these two are already in graduated phase, LinkerD is in incubating state. So I think there is and LinkerD is Istio, heard of it. So this Istio will also come under the same category of mesh, service mesh, LinkerD area. So Istio also is a alternative for LinkerD. So yeah, yeah. So this Envoy is it is completely. I mean, it is picked up so quickly in the space of service proxy, and it is helping to enable route the traffic and identify various services and route and proxying the traffic. So that part is where Envoy shines. So yeah. So summary. This of course, when our microservices are growing, so you need to manage the features of load balancer, routing, and mesh. So that's where these tools in CNCF landscape will help. Any questions? Well, yeah, let's quickly check Envoy. So actually, this one is Lyft. Lyft is a company equivalent to Ola or Uber, right? So it's very popular in the US. So Lyft is a main contributor of this tool Envoy. So it's open source edge and service proxy designed for cloud native applications. So that's where this is primarily created by Lyft. Of course, a lot of people who are already using like AWS, Booking.com, all of the big names you can see here. It has become so popular. Now everyone started using this feature now. So just to summarize, the area where this concept of the service proxy. First, you should know what is service proxy. So, service proxy is an area where it will give you all these features, like for example, HTTP2 support, gRPC support. These are the two popular frameworks now. HTTP is the older version, but HTTP2 supports more. I mean, they're very new HTTP2, and a lot of browsers just now started supporting HTTP2, but older version is 1.1. But HTTP2 is now an advanced version of HTTP protocol. So many applications still support 1.1. Even some of those are still 1.1. But HTTP2 has a lot of popularity, and gRPC is one such protocol which supports the HTTP2 features in a big way. So it's a Google product, remote procedure call. So that these two frameworks support load balancing, then configuration management, then observability. So observability is more a load balancing feature, more in terms of observing the traffic, and also distributed tracing and observability of various DBs. So this is where the center features are all called as service proxies. Managing more services and with on top of that giving a load balancer and configuration management and support for gRPC. So that's where this Envoy shines. So it is from Lyft. And I'm not going to detail. I think we can go to that more specific session of that. But more the LinkerD is something similar to Istio, which is also very popular. So LinkerD, there's a big fight, or not fight. I mean, it's a competition that is between Istio and LinkerD in the space of service mesh. So I mean, Google's promotion is, I mean, Google's product is Istio. I mean, it's not Google's product. It is Google initially created that product, and it is open sourced to the Cncf community now. But I think LinkerD was introduced like a couple of months before, and by the time Istio came, LinkerD was already getting popular and many people started using it. So there's a stiff competition going on between LinkerD and Istio. But at the end, both are service mesh tools. So what is service mesh is mostly when you get the basic services. Kubernetes manages most of the services, and it will give you a proper load balancer with all these tools. But if you have to take care of the day two problems, like you need to look at you need proper metrics to monitor the health of the services, and also there is a security aspect, and also the data transferring between one service to microservices, managing that in efficient way. So these are the improvements that we can make on top of your microservices. So of course you can individually solve each problems, or you can take a framework like LinkerD, which already solved this problem for you, or you can customize it for your own needs. But this is a solved problem. So all these data problems of a complex microservices are already solved by frameworks like LinkerD and Istio. So it's obvious choice to use these tools rather than reinventing the wheel. So that's where this tools LinkerD is offering you more platform health metrics. Mostly it gives the status rates, latencies. These are all metrics that you need for your production problems. So it gives complete health information of your microservices, and also it gives minimalist Kubernetes native design, no hidden magic, as little YAML and few CRDs. CRDs is one area which we need to look at. It is very custom to the definition, so which is a very popular framework in the Kubernetes space. We'll come back to that. So this is offering all these features on Kubernetes specific tools, TLS, security aspect. So it will give you security aspect, like these are self-control control plane. So completely it's all a lot of diagrams and debugging tools are introduced in this, so that it can solve all your server problems, all your data problems, or storage problems. Are all there are a lot of inbuilt tools available for diagnosis and debugging. So drop-in reliability features. So you can add latency-aware load balancing tools, retry mechanisms that handle timeout problems or blue-green deployments. These are all again features. These are all once you're live. These are the common day-to problems that we need to manage. So and also ultralight, mostly it's a lighter framework written in Rust for security and performance as well. So summary. This is all helping to manage your microservices. That's where LinkerD is helping you. So at the end, it's a service mesh which is giving you the health metrics. It is giving you the mesh design. It is giving you the security aspect, which is completely TLS based security, and also it is giving you the reliability aspects of latency management, retry problems, timeouts, and all this stuff. And this more is fast. So that's where LinkerD shines. And if you look, of course, CoreDNS, I'm not going detail. I'm looking at the DNS management. Let's quick go through that. But I think it is at the end, it is the DNS tool where this solves the problem of every IP, of course, giving a DNS name on top of that. It is completely a tool for giving a DNS server. So written in Go, multitude of environments. So you need to handle a lot of pods, and each pod will have an IP addresses, and it's difficult to remember the IP addresses. That's where DNS will give you an additional feature. Yeah, so nothing complex. It's just a DNS management, and on top of that, it gives features of service discovery. You can discover services very quickly if the DNS is there. So you can apply a label in Kubernetes, where label DNS is equal to, for example, agile rules. So it will fetch you all the agile rules, for example, company-specific microservices. So likewise, our project A. So likewise, you can give DNS, you can filter the records and fetch you those specific microservices. So yeah, so similarly you have logic. You can write in transformation rules or whatever you have. So everything that can be written in a template format in this language. So then it's a more of a DNS management tool. So that's where this shines. So let's move on. Here, any questions here? Okay. So next is the networking. So policy and security space. So in this, of course, you have all your applications deployed, but I think again, as part of your day-to-day problems to manage, every enterprise should be flexible enough on the networking aspect. I mean, they're already already there's a networking vendor for all the enterprises, so they should be free to use those existing vendors as much as possible. Probably they are not compatible to Kubernetes, the network providers. So to make them compatible, so they need a middleman in between. So that's where the networking tools like Calico will help you to greater extent. So it solves the problem of managing your network. Calico and Flannel, in fact, both. These two are Kubernetes networking solutions. And then, of course, WeaveNet is also, Calico, Flannel, and WeaveNet. These three are popular tools in the space of networking, where they are all like CNI compliant. CNI compliant. CNI is our framework for the Kubernetes ecosystem. So the CNI framework is again set of standards on how a networking should be applied in the Kubernetes world. So it's called CNI, stands for Container Native Interface. So Container Native Interface. How you handle the networking for a container. So that is a networking project, and that networking project gives some guidelines, and those guidelines were implemented, and they are more specific to Kubernetes, and those guidelines were implemented by these guys like Calico, Flannel, and WeaveNet. So so that's about the networking aspect, and then next comes your policy management. So policy management again, policy is again set of rules. So who can do what? So a policy you should define network policy only. This set of probably this microservice can talk to only this microservice. So there's a policy or rule that you want to define, or you want to write a rule saying that microservices can use this size of nodes only. So this is your RAM, highest RAM that you could use, or highest CPU that you could use. These are various policies. So basically these are a set of general guidelines or rules. Typically they're all before OPA came. They're all written in some wiki pages, but no one really follows it. The real implementer who is doing it is really not following it. So how will you ensure that this is followed, that these rules are followed? That's where this OPA will come into picture. As long as you integrate OPA, Open Policy Agent, in your tool, this OPA will monitor your resource, Kubernetes resource, and it will ensure that every Kubernetes object that is getting deployed is following the rule that is mentioned in the OPA. So if the rule is violated, it will not deploy that Kubernetes deployment. So that this enforces you to follow some set of guidelines across organization. So that way it is enforcing you to follow some set of rules across the organization. So that's the space where this OPA tools, OPA is a proper tool in that space. Again, it is in the incubating stage. And next, of course, this is as you see here, is a general purpose policy engine. It's a policy engine with users ranging from authorization and admission control to data filtering. So it ensures, I mean, it takes care of whether you're authorized to do some activity on Kubernetes and what is your admission control and in which areas or what areas you can apply or you can filter the logic or whether you can send data to some microservice or not. So all that management of communication between microservices is also completely managed by OPA. So yeah, so that's where OPA will come. Again, this is also something running as a sidecar container, so which will ensure that the across services traffic is completely monitored and goes via OPA. So yeah. And next is Falcon.
So OPA is a perfect agile rules, man.
Yeah. But this is, I mean, it's a rules, but I think it's more rules applying on Kubernetes objects. I mean, that is simpler terms. So rules applied on Kubernetes objects.
The rules are relevant always, wherever you go. Today Kubernetes, tomorrow it could be Kubernetes. The rules are there. You should be agile.
Yeah, that's true. So that comes under policy management. Then next is security. So of course, security is Falco is one popular tool in the cloud native ecospace. Falco is it completely gives anomaly detection engine. So that is the area where so that is it is under. So it looks at your anomalies in the communication between microservices, or it could be from the logs it can detect and identify the security threats. So that is a space where the Falco is available in the Kubernetes landscape. Yeah, I think probably let's go in deeper into this Calico, Flannel, and WeaveNet in a separate session. I think this is a very interesting area to watch out. This area is going really very fast. This networking area. So, then of course you have. Apart from this, you have a lot of Kubernetes-specific databases and storage platforms. Of course, the Kubernetes you can deploy any database for that matter, but if you're going towards a Kubernetes ecosystem, so it is good to use a database which is certified by Kubernetes in the space of distributed database category. So in that space, one very popular tool. I mean, MySQL is a very popular DB. So on and MySQL is not completely compatible with Kubernetes. So Vitess is one such tool which is making MySQL compatible and addressing the problems of scaling and sharding. I mean, MySQL has a limitation, even though it can support huge volume, but if it has to go beyond, it needs some extra scaling and sharding mechanisms, which are completely missing in MySQL at this point. So that is where Vitess tool is one such tool which you can use on top. At this point, it is restricted to MySQL, but I think slowly this area will grow to other databases wherever they're missing. And Vitess is, by the way, this is a tool from Google. So there, in fact, YouTube and is one more application in Google. So it is still using MySQL, and that's where they realized this. I mean, to the scale of where YouTube is going so popular now. So they soon realized that MySQL couldn't address the scaling problems. So that is where Vitess came into life. where the Google engineers they developed a layer on top of MySQL, which they open sourced to CNCF. And yeah, so that's about the database side. It's not a very big, it's just MySQL only tool, nothing specific with other tools yet. But MySQL is still more popular in the open source world, so I'd say this is popular now. It's already gone to graduate stage. And Rook is storage category. So you need to there are a lot of storage that vendors that you can integrate. I mean, there are a lot of storage vendors available in the market. So of course, S3, Amazon S3 is one storage which is from cloud. But otherwise, in open source world, there are a lot of storage vendors available. So Rook is one such storage orchestrator in the space of Kubernetes. Sorry. So of course, I mean, just to give some ideas, the Rook gives you, let's say you want a pod, and you are telling that my resources for this, a node. When you're creating a node, you want to give storage restrictions to the node or even to the pod file in any Kubernetes object which requires storage. So you can I mean, so far we're talking about orchestrating the Docker containers, but the orchestrator of the containers, it's not restricted to containers, can be applied to storage also. So that managing the storage is a bigger problem. So that is where Rook is solving that problem. So it has integration with all the popular storage vendors, and it is giving compatibility of the storage attaching to Kubernetes objects. So that is where this will fit. And then of course HD is already it's also comes from the database category. It's already used by Kubernetes. But Kubernetes uses HD as its own database. So if you remember the architecture when we discussed about Kubernetes, HD is a DB time series DB within Kubernetes, already used by Kubernetes. It's actually category service, the brain of Kubernetes. HD provides a reliable way to store data across clusters of machines. So at any given time, Kubernetes maintains the health of the clusters or nodes in the cluster. All the information is already stored in HDDB. So of course, it's not just for Kubernetes. It's an open source database. So that also can be used, and it is completely Kubernetes compliant. So yeah, that is one area. Let's say if you're looking for a time series DB, then HD is one such popular tool. It's already used by Kubernetes and it's already proved. And next is if you're looking for a distributed transactional key value store DB. So and this KB is one TAKB. TAKB is one such popular tool. It is written a lot of many people started using it. I think it's still in incubating stage, but I think very soon it will move to graduate stage. There's a high performance distributed transactional key value store DB and written in Rust. And Rust as a programming language is becoming so popular now. So I think many companies have all the modern programming language, modern developments are all happening in Rust. It's more of a C++ or system programming area is where this will fit, like C++ or C. So yeah, this Rust is programming is many popular tools in the CNCF are built on Rust and Go. So Go is another language. Rust and Go are the popular modern languages now. So yeah, so that's about the DB. So summary: Vitess, MySQL sharding feature, Rook storage orchestrator, HD, the time series DB, and TAKB is a distributed transactional key value store DB. So yeah, and of course the messaging area is always a popular area. So between two microservices, if you have to store the data, so there is a messaging layer is very much required. So I think very popular tools that we know are Kafka. Kafka is one very popular messaging layer that sits between microservices. But I think it is all built. Kafka are still popular and it is still used, but but it is but Kubernetes specific compliant tools. If you see in the messaging layer, NATS is one such tool, which is an alternative to Kafka. So this will completely serve whatever Kafka is for messaging layer. This is obviously there's a when you say messaging, there is a publisher and there is a subscriber. So all the publisher will publish a message to the NATs, and on the receiver, whoever is subscribed, they will receive that message. So that's the area where NATs will fit in. And gRPC is a framework where this is more compliant for. I mean, we're all popular with the HTTP. HTTP has always when you have to transfer a lot of messages, HTTP it doesn't fit for huge data intensive applications, or you're looking for a super fast client server communication. HTTP has a limitation. Of course, HTTP2 has come, but still HTTP2 is not ahead in the implementation yet. I think a lot of probably in 1 year time it will become popular, but HTTP2 is still in the nascent stages. But right now, if you're looking for an extra fast communication between client and server, gRPC is one popular framework which is coming into the space of client server communication. So of course it follows the JSON REST model, but it follows the RPC concept, remote procedure call. So RPC is a very old concept. So I think it is just reinvented that concept, and again it was introduced by Google. So Google, all the products which are in Google, most of them use gRPC. They eventually migrate from HTTP to gRPC. So yeah, it is already tested, piloted for all the Google products, so you can safely bet on the gRPC. Then comes this managing the events. So how will you manage the events, especially the event streaming or event messaging. So event messaging is based on some event, you need to take some action. So this event mechanism is a very popular, whether you go in cloud or on-premise. This event mechanism is very popular now. So based on some data you store, you want to take some action. So or you want to as and when you inserted a record into a DB, you want to take some action. So these are the various common use cases. So to manage that, some paper called cloud events is more it is more a specification as such, primarily for event data management. But this is a specification, but this implementation of specification is now getting popular. I mean, all the cloud vendors are now following the specification of cloud events. So all the popular event framework tools in the cloud, so they are completely following this specification. Yeah, this is a specification that becoming so popular now. So and next comes this container registry and runtime. So this, of course, Docker Start is a one popular container tool that we know, but Docker has some limitations when it comes to storing the data. Of course, in the space, it is primarily, first of all, it is not OCI compliant. And OCI is one set of processes that like every container should follow some set of rules, and that is it's a vendor neutral specification for container management. So this specification OCI compliance is becoming. I mean, it is quickly implemented by Containerd. Containerd is alternative to Docker. So if you want to move out of Docker, then Containerd is the next bet. So yeah, it's already in graduated phases, and in fact there is a Docker is widely adopted, but still has long way to go. But I think Kubernetes want to be the container runtime should be it wanted to be an OCI compliant runtime. So it is Docker is still not OCI compliant. But Containerd is a OCI compliant. So eventually the Containeرد's growth will happen, but it is still Docker is leading the journey in this case. Yeah, and then of course you need to register all your containers, right? As you store a container repository, we discussed about a lot of container repositories in all the cloud vendors. But if you're looking for an open source container registry, so where you can store all your container images in a container repository. So that's where Harbor is one such open source tool, where it can store your containers and also it can sign. Sign is for security aspect. So you can sign a particular container image and also it can apply scanning of your container image. So Harbor is one such tool. And of course, the same area, OCI compliant Docker alternatives, Cryo. Cryo is another Docker alternative, still but is in incubating stage, but it's also getting popular. So, I mean, to summarize, Docker alternatives graduated is Cncf graduated is Containerd. Other alternative which is incubating stage is Cryo. So these are Docker alternatives. So these two are container runtimes. But whereas if you're looking for container repository of containers, then Harbor is one such tool, open source repository, where it will store, sign, and scan the content. And I think the last one in this category is software distribution. So this area is more okay. You have a solid image, which is a working image, and now we want to distribute this into a wider group. So how do you manage that? So that's where the security aspect will come into picture. So only the signed images should be distributed. So in that case, how will you ensure that your image is signed properly, or it is, how can you stamp it or make a notary of it? So that is where the specification of what or how what are the criteria to make this image is compliant. So that specification is given by TUF. So TUF is a framework which tells you what are the characteristics for a signed container image, and Notary is an implementer of that TUF framework. So yeah, then it is it authorizes you what are the images that you're storing in some container repo, Harbor or any other container repo. So at the end, this gives a final touch of saying this is compliant in all aspects, and I'm giving a stamp so that now this is ready for distribution. So that final touch is all given by these tools, the CNC.
So perfect, right? So we saw all the 10 categories. You know who is sponsoring the CNCF primarily?
Primarily Google. Google is a major contributor, but I think now a lot of other tools, all other vendors also they're equally contributing. I think.
Yeah. So this is basically in those days user groups. This is the more matured user group, kind of. They brought all this what Google cannot compete with AWS or Azure. So they very smartly did this effort so that now AWS and Azure has to catch up with these standards, because these are all going to be de facto standards irrespective of cloud or not. So yeah, so very
It's a
smart.
governing body, right?
Yeah.
That's the thing. So which is like stamping. Yeah, once you need to have it in a Kubernetes kind of environment. Even though everything is open source, they are kind of making sure that they come through their organization. Yeah,
Correct.
it's a smart thing to do.
Very smart way. So that now I think because of this effort, their penetration into cloud is going to be good because of this. And AWS is really facing a huge. AWS is simple, and they don't care for all these jargons. They make it work. They give you very reliable as well as very cost effective. But now this brings back the equation. Okay, we want to put all the standards and so on and so forth, so that now AWS has to adhere to these standards to be in the market indirectly.
Yeah, I think if you look at a lot of frameworks have evolved, so that is very interesting to watch. I mean, this space. So, for example, here OCI compliance. Right? So, every container should follow some compliance rules. So that is it's just in incubating stage, but soon, very soon, this will be widely adopted. So any competition in this container runtime. Now Docker was a monopoly, but I think now Containerity and Cryo are coming up in that space. So, so someone is giving you complaints and you follow that. So that shows the credibility of the tool. And here also same notary. Tough is a software distribution notary framework, and that is compliant. This is compliance, and that notary is a one such implementer of that compliance. So yeah, so likewise, cloud events is also on the specification of how an event handling should be. So that's also a specification. Um, when such specifications come in the market, then the specifications are coming because there are a lot of each vendor is following a different format, so they want to bring some uniformity. So when uniformity comes into picture, then automatically the tools which are following that specification will also become popular. So, whether you do or not, eventually you should follow that because that is a standard. So similarly in the open tracing side, so tracing has become so a lot of vendors were there in the tracing issue, and that's where Google realized that this is going somewhere. So I think they introduced this concept of open tracing implementation guidelines. So that is the open tracing framework they introduced. I think Jaeger is one such implementer of that framework. So yeah, this space is a lot of open source tools are there, but I think whoever follows this particular specification will win the market. So that is one area where we can see that the Kubernetes ecosystem is really growing with a lot of standards and frameworks around, and, uh, and tools complaining to those frameworks are also growing. So, I mean, what we saw is just a very smaller piece of a bigger ecosystem. So this is all important tools for a developer aspect who are involved in the microservices implementation stage. But if you see here on the this is one we already saw this in the last session. So there's a lot of the same category, a lot of tools. I think whatever we saw here are the big boxes. So that is the summary that we saw there. So database
No,
side.
whatever you saw there is kind of promoted. It's like, for example, if you go to the menu restaurant, you want to see our popular products. What is that? Is what that one is, and that's what I meant. The whole thing is a very good marketing gimmicks,
Yeah,
and so
yeah, that's
I
true.
think one of the biggest way Google will survive because of this effort.
Yeah.
So, Srini and Shyam,
Yep.
so this is slightly different kind of a question. I think most business applications, something you take like Oracle or SAP, or later which came things like Salesforce. They all have their own cloud platform, and they are running huge applications for the corporations. At the end of the day, for business to run, how these applications are are being used in this, or the other way I'm just trying to ask is, these standards are not yet used across the three giants, Microsoft, AWS, and Google. So you're not going to see all of them going to agree on something like that. Even though Google wants to drive something, they just like everywhere else. There will be always a splinter group, and after some year it will break away. So just want to ask you what you find in this area. What do you see
Yeah.
the
So
application
Anna,
area
just now we talked about it.
application of
Basically,
these giants?
yeah, this is very good. Google's marketing, one of the best marketing. If you see, if you think about, right, goodwill prevails, right? So what Google has done is, I have some very good tools, and there are many other people who has a very good tool, and we all have to compete with the big giants like AWS and little bit on Azure. So they are the most competing forces, especially AWS, then the Azure side. So now, if you frankly ask the customers, they don't care for all the standards and so on. I pay little, I want to get the reliable service. It should be fast enough. Those SLAs to be met.
That's it.
That's it. I don't care. All this crap. These are all the craps by the developers and architects, and to make our. If you put more, you know what? To be honest with you, I survive in this industry if I have more of these things. So that I go and I talk, I make others impress. I get the big. I will be paid for it. So
But how are you solving customer problem?
Actually, there is no means like the customer problem means or like there is a force, right? Like which says that you cannot stay on the old platforms. That's the way they are projecting and marketing this. And there is they say like it means the sugar coating they give is like, yeah, you will not pay that much. It will be like pretty much on the cloud. You don't have to own all the servers and other things, but the problem, whatever with the application, remains the same. It's just that it has moved to a different platform. I think that's, if you really want to solve the problem, that's a product level thing. Actually, this is like maintaining. It's a platform. What do you call that? PS. I mean, PaaS, right? Like platform as a service. Yeah.
Okay. Interesting years ahead.
Mm-hmm.
Yeah, and I think the tools are. I mean, these are all tools to help some of the problems, either to take in database or in streaming or in CI/CD or I mean, so we have a lot of tools already in the market in the same space, but just everyone is moving towards Kubernetes. Uh, so these tools are a flashy tools where it can help you in your Kubernetes journey. So because these tools are becoming popular just because of Kubernetes as a main person outside. So since everyone is moving towards Kubernetes, as a cloud or on-premise or whatever, because it addresses many problems, and and the Kubernetes is just solving the deployment problem or kind of managing the containers and in an efficient way. So, but it's not solving all the peripherals around the day-to problems of your production deployment. So that's where these tools are helping and considering that they are Kubernetes complaint or OCI complaint or streaming complaint or events complaint. All these tools along with this Kubernetes touch is all eventually getting popular. So, but if you take if you ask, all these tools will become popular in 2 to 3 years from now, may or may not. But uh, but the Kubernetes is growing very fast. So whatever tools which are under graduation phase, it it has not come to graduation phase in 1 year. It has come to graduation phase in 5 years. So it has crossed a lot of hurdles in this process, and a lot of improvements happen in these tools, and a lot of community has contributed in the open source world, and many people have already used these tools in production. So these are the various criteria that CNCF as a governing body has put for upgrades in all these tools. So summary, any tool which is in graduated phase, so it is a mature product in the Kubernetes ecosystem. So and the best part is they're free because they're completely open source. So and also if you are going to cloud, your cloud vendor who is giving Kubernetes may not be compliant in these tools yet. So yeah, you are free to use Kubernetes in cloud, but wherever there are some features missing, you can use these open source tools, which are CNCF graduated tools, and it will help you to move faster. So if you ask Salesforce, for example, which is completely on cloud, right? So they're underlying they are using Crystal Kubernetes, even though they are for end user it is a cloud solution, it's a SaaS solution, but to deploy there as a SaaS product into some platform. So they're still using Kubernetes, or they may or may not be using, but mostly they're using, because I see Salesforce is also a popular vendor in this Kubernetes ecosystem. So yeah, so I mean the community is growing very fast. I mean these boxes are they didn't came in one day, right? So they came over the last 5 years, and the CNCF events which I attend. I mean I was attending these events from some CNCF every year. They conduct some events. This the popularity of this CNCF events on this talks about the CNCF tools. The number of audiences who are reaching the last 3 years is skyrocketed. So yeah, so there are a lot of people around the world who are interested in this CNCF ecosystem. So they're very eager to participate in the CNCF events. Now, in the last year, there's gone virtual event, but I think this year is coming next month. So CNCF event. So it is good to register. A lot of videos are also there on YouTube about these products, which you can also go through. Yeah, this is a new area which is emerging, but I think it takes some time for the incubating stages of projects to go to graduated phases. But I think graduate phases projects are sure shot we can rely upon.
Okay, my connection got disconnected, so I'm back. I think you guys are wrapping up, right?
Yes, yeah, we're done.
Okay, sounds good. Yeah, we'll meet again.
Have a good weekend.
Yeah, I'm going to meet Nani today. We are going to buy some Home Depot stuff for the outdoor gardening, okay?
Enjoy, it is only 90 degrees.
Wow, thank you.
Wow, enjoy.
Bye.
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 Right.
Okay, thank you, bye-bye.